In this video, we are going to explore sockets and how they facilitate network-based interprocess communication. Sockets are endpoints for communication between two processes over a network. They serve as the communication mechanism for network processes and are identified by an Internet Protocol address and a port number. Sockets enable bidirectional data transfer and form the foundation for network applications. There are mainly three types of sockets. First one is stream sockets, which use Transmission Control Protocol, also known as TCP. These are connection-oriented, providing reliable and ordered data delivery with error checking and flow control. These are typically used for applications requiring data integrity. Second one is Datagram Sockets, which uses User Datagram Protocol, also known as UDP. These are connectionless, offering no guarantee of delivery or ordering, but provide faster speeds with lower overhead, making them suitable for speed-critical applications. Third is raw sockets, which provide direct access to underlying protocols, bypassing standard protocol processing, allowing custom protocol implementation, but require elevated privileges, and are used for network monitoring and security tools. The socket programming model involves several key steps. Initially, a socket is created with a specified domain, type, and protocol. On the server side, the socket is bound to an address and listens for incoming connections. A client then initiates a connection to the server, which the server accepts. Data exchange occurs through read and write operations. Finally, the connection is closed when communication is complete. Several key application programming interface, also known as API functions, are essential in socket programming. The socket function creates a new socket of specified domain, type, and protocol. The bind function assigns a local address to a socket. The listen function marks a socket as passive to accept incoming connections. The connect function initiates a connection to a remote server. Additional socket API functions include the accept function, which accepts an incoming connection on a listening socket. The send and receive functions transmits and receives data on a connected socket respectively. The send to and receive from functions are used with connectionless sockets, for example, User Datagram Protocol. The close function closes a socket and terminates the connection. On Windows operating system, close socket function can be used instead. Here's a basic transmission control protocol, also known as TCP server example written in C language. This code snippet demonstrates the fundamental steps to create a server socket, bind it to a specific address and port, listen for incoming connections, accept a connection, send a message to the client, and then close the sockets. Here's a basic transmission control protocol, also known as TCP client example written in C language. This code creates a client socket, connects to a server at a specified Internet Protocol address and port, receives a message from the server, prints the message, and then closes the socket. Socket options and configurations enhance socket functionality. So _reuse address allows the reuse of local addresses and ports, which is useful for server restarts without waiting for time wait to expire. So _receive buffer and so _send buffer sets the receive or send buffer size for the socket, affecting throughput. So _keep alive enables periodic transmission of messages on a connected socket to detect if the peer is still alive. Transmission Control Protocol, also known as TCP_NO delay, disables Nagel's algorithm, which buffers small packets to reduce network traffic. For socket programming, it is a best practice to always check the return values from socket functions and implement proper error handling to ensure robust applications. It is also recommended to use non-blocking sockets with select, poll, or ePoll for efficient handling of multiple connections. To ensure security, we should validate all input data, implement proper authentication, and consider using transport layer security or secure sockets layer, also known as TLS or SSL, for encrypted communications. Lastly, Always close sockets when done and implement proper cleanup in error cases to prevent resource leaks. Sockets provide a powerful mechanism for network communication between processes, forming the foundation of distributed systems and network applications. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.